Hi guys, it's Miss Red again. Okay, so last week we've been studying phase changes and we've learned about kinetic, potential, kinetic, and all of that. Today we're going to learn the quantitative side of that. We're going to learn how to calculate the heat that is involved in making all of this happen. Whether it's heating or cooling, heat is either added or removed. So, what's the difference between temperature and heat? Well, temperature, as you should know, is the measurement of average kinetic energy, while heat is the total energy. It's both the kinetic and the potential together. Kinetic, furthermore, is the energy of the movement of the particles, right, which is associated or measured by temperature. Potential energy is the stored energy, and we cannot directly measure that. Like you can't put a thermometer in and know the potential energy. Okay, so you know when you heat a substance, the temperature rises. How much it rises and how quickly depends upon its specific heat capacity, which is a capital C, is its abbreviation. And again, it's how much heat is required to overall increase the temperature of the sample or the substance. Now, specific heat capacities are different for different substances. So let's think about it. If you have a steel pot or water, right? You have a pot full of water, which heats up more slowly, right? Which takes more energy to increase, because that's going to be the one with this higher specific heat capacity. Think about it for a minute. Pause the video if you need to. What gets hotter slower, the pot or the water? Okay. So here are some numbers. Steel has a specific heat capacity of 0.466, water 4.18. So the higher specific heat capacity is water. And what does that mean? Well, it heats up more slowly. Right? It's going to take a lot more energy for water to get hot than steel. Steel gets hot pretty fast. Okay. Oh, here are some formulas that we're going to learn how to use. Q equals MCAT. The delta sign is often referred to as MCAT, like an A, but it's a delta. Delta T is final temperature minus initial. Okay. So let's do a practice problem. How much heat is required to heat 4.3 grams, that's mass, of water from STP, standard temperature can be found in your reference table, to 300 degrees Celsius? Pause the video and practice. Okay, hopefully you paused the video, got out your calculator. Let's go through the steps. It's MCAT, where the mass is 4.3. For water, look in table B, the heat capacity is 4.18. And notice it's 300 minus 0. We use Celsius because Celsius was used in the problem. And so 300 minus 0. And then you round to 2 sig figs and you get 540 joules. Joules is the unit for heat. But what if temperature is not changing? Remember, during a phase change, temperature does not change. So let's try this one. How much heat is required to melt 4.3 grams of water at STP? What is the key word in that problem? Melt. The key word is melt. That's going to help you choose the right formula. Melting is Q equals MHF. Fusion is melting. Pause the video and actually solve the problem. Okay. I hope you stopped and got your calculator. Put the numbers in. Notice there's no temperature. They give you a temperature in the problem, but it's not necessary. Temperature does not change in any way during that phase change. And when you round with sig figs, you get 1400 joules, again, is the unit. Okay, let's try one more. How much heat is required to boil 4.3 grams of water at STP? What's the key word? Yep, boil or vaporize. So what formula? Q equals MHV. Okay, V for vaporization. Pause the video, do your calculations. Okay, let's see if you're right. You put in the numbers. Notice again, they give you a temperature, but you don't need to use it. It's not in the formula. and it rounds to 9,700 joules. Okay, hopefully that gives you a good start. Hopefully you wrote this down, or we can watch this video again. Good luck calculating Q. That's all.